actually kick this off. And I think, it is being recorded. Rian, I think you said you're gonna try to assist me there with the recordings and stuff like that. So, and how to share it to everybody. But I know it can be also saved on the Teams website or the Teams stream. But let's see how we can do that. And then I just think let's take it as as a start, and then I thought probably on Thursday I want to make it an hour, so I'll probably change some of the invites again to make it a bit longer, so that at least you guys can get more time, and then hopefully by Friday they give us a different date for your exam. That's really what I'm hoping for. But yeah, let's take it from there. So I'm hoping everybody can see my screen, the one that I shared, and also I am checking on myself and on the chat. So if there's questions in between that you want to ask on the chat, please do so. We're also still a smallish group. If I look, we 20 guys. So if there's really a issue that you want to ask a question or something like that, you can also unmute yourself. I don't have, if we're a small group still, it's not the issue. But otherwise, basically, I want us to, as most of you said, a combination of exam papers and probabilities. So I thought, okay, but I basically looked at the May-June 2018 for now questions, and I started at question 9, and I think I also want to get your inputs here first, if this is nearly where we need to start, because I think if this is the start of probability, and I rather that we get the easiest stuff, that we understand that enough so that it's in a sense easier marked in the exam, and wherever other stuff can be more difficult. So I thought let's start with this. It's the papers on the website is terrible if you look at it, and so I think for the next round as well, if you can have it with you, but what I like to do is actually, and I have loaded it on the file or on the folder as well. There's a files folder, so I'll take a few screenshots later and send that on as well. But it is there, but I normally like to just scribble on a page and let everybody see what we're doing. So I thought let's start at question 9. If you guys feel we need to skip a few, we can, but I thought it's important for the exam and in everything that we're going to do, and let's rather use red. Red comes out better, but we need to understand what's mutually exclusive. We need to look at independent, and then how do they phrase it in different words. So nearly for the first one that we're looking at, and in your exam, what I now could pick up is what they tested also with the assignment that you did online. And not that I like it, but the way that they are going to do it for this exam round is basically they're going to give you, like in that assignment, you will not be able to go back to questions if what I could pick up, because they are afraid that we use for WhatsApp and those kind of stuff to communicate. So it seems like it will nearly be a random questions in the exam, and then there's no opportunity to go back, which I don't really like. So I did give my feedback to them, but let's take it as how it probably would look like. So the first question that I want us to look at is a probability. So it's the start of a probability, and it is basically asking us, so supposedly that we've got a probability of A that's equal to 0.5, we've got a probability of B equal to 0.3, and which one of the following is incorrect. And I think that is also one thing that you would pick up in a lot of the questions that we did in the assignments. They like to ask the incorrect one, and then suddenly the next one they ask correct, and it's very easy to make the mistake between the two, because your mind is nearly like already in looking for the incorrect one, or in the process always looking for the correct one. And obviously, as you would have seen in your assignments, sometimes they change the question, but then they don't change some of the answers, and then you get that you get some of the assignment that the questions was wrong, just because they changed it and didn't realize they changed wording as well. Okay, so let's go back to the question. So when we look at something like mutually exclusive and independent, so if you are writing an online exam, what I would suggest as well is, even if you take the notes that I made or make your notes yourself, but that you actually have notes with you to say what is mutually exclusive and what is independent. Because I think that is nearly will help you when you get some of these questions. So the first one, when we look at mutually exclusive, so mutually exclusive is when, and let me see if I can write it. So when we have a probability of A times probability of B, and again, I'll share this afterwards, so don't worry. Probability of B is equal to 0. So that is when it is mutually exclusive. So if you look at this question, probability of A or B, so normally how we work that out is the probability of A plus the probability of B minus the probability of A and B. So for this one, it would have been 0.5 plus the 0.3 minus 0. So then it is 0.8. So for this instance, that answer is correct. Again, we're looking for the incorrect one. So when is something independent? So that is when the probability of A and B, so let's just try, I must get myself a better equipment. A and B is equal to probability of A times B. Okay, so in this instance, we can definitely see that probability A times B will be the 0.5 times the 0.3, so that will actually be equal to 0.15 if I'm working it out correctly. So for the probability A or B, for when it is independent, it should be 0.5 plus 0.3 minus 0.15. And that obviously then is not equal to 0.8. So definitely that one is the one that is incorrect. Thanks, Rian, for handling all the WhatsApps as well. Great, thanks. Okay, so then automatically we know which one is incorrect. But let's look at the other two or other three options as well. So if, and I like to start at the bottom one because that's the more easier one. So if A and B was equal to 0.2, we know that A plus B is 0.8. So if we then needed to work out the OR, it is the 0.8 minus the 0.2, so we will get the 0.6. So that is also correct. If events A and B are mutually exclusive, then the probability of A given B is equal to 0. I just want to add here probability A, and instead of and, I'm just going to do that. So the probability of A and B is equal to the probability of A times B, which is equal to 0. So if it is mutually exclusive, the probability of A given B, and that formula is actually the probability of A and B divided by probability of B. So if it is mutually exclusive, we know the top part is going to be 0. So 0 divided by anything is 0. So automatically then that is also correct. So, and then if events A and B are independent, then A given B is equal to 0. So let's use the same principle. We have worked out what A and B is when it is independent. So it should be the 0.15 divided by the probability of B, which is 0.3. And then 0.15 divided by 0.3 is 0.5. Okay, so that is, so it's very, not easy, but it is very, very clear that the second one is the incorrect one. But I think, again, it is, you nearly need to know the formulas to understand what you need to get to. And for me, the most important one is what happens when something is mutually exclusive and what happens when something is independent. And that is nearly the most difficult what they can ask you for these questions. So, and how I normally like to do these sessions is just check on a thumbs up if you guys are happy with that, and then we can go to the next one. And if there's anything I need to explain again, also please ask. Because I think, again, it is the second one nearly is very similar kind of thing that you need to do. So let's do a second one just as an add-on to the first one. And yeah, I can see it's already 15 minutes, so Thursday we'll make it an hour, and take it from there. So, okay, so they tell us the probability of A is 0.4, the probability of not B is equal to 0.5. So if I see that, then I already know that the probability of B is equal to 0.5 because it is 1 minus that. We're looking for incorrect, so already I know that one is correct. So unfortunately, it's not a short answer. We need to go to the next one. And maybe let's quickly see. So, and this is how I would do it in the exam. So yes, I quickly did that, but let's see. Probability A and B is equal to 0.1. Okay, so is it mutually exclusive or not? No, it's not. Otherwise, the probability of A and B would have been equal to 0. So events A and B are not mutually exclusive. Okay, that is correct, unfortunately. So let's look at the next one. Let's see if we can quickly see if that is correct or incorrect. When we say probability of A times B, that would be then the 0.4 times the 0.5, which is 0.2. Okay, and our answer is 0.1. So it is not independent. Okay, so if it was independent, the probability of A times the probability of B should have been equal to the 0.1. So it should have been equal to that because that is what they are giving us, and it's not because it is 0.4 times 0.5, which is actually equal to 0.2. Okay, so that one is the incorrect one, and that is nearly how I would do it in the exam as well, is to look for nearly the easier ones to work out first. I will not work out something like that first because then I need to divide and remember what the formula is and things like that. But if we needed to do that, it would have been the probability of A and B, which they give us as 0.1, divided by the probability of B, which is 0.5, and that would then give us that answer, which is correct. And if we had the normal one of probability of A or B, it's the probability of A plus the probability of B minus the probability of A. And so it would have been 0.4 plus the 0.5 minus the 0.1. So we would have gotten that answer. So yes, I think this is, these two was I think to the stretch that you can go with a normal probability with mutually exclusive and independent, and in the exam there also will be about two questions for you. So I think that's the simplest part of probability, and again, what is most important is the mutually exclusive and the independent one. I think everybody happy with that. So then the next section of probability is nearly when we start to look at discrete binomial Poisson in the next chapter. And here I think also previously it was nearly, if you look at the tables in the back, it could have given you a guidance, or tables in your exam paper would have given you a guidance on what kind of questions will be asked. So I don't know now how that will be dealt with. So I think I will ask the lecturer as well how they plan it. So if you get a Poisson question, will there be a Poisson table, or will you need to open up a different screen or things like that? But the first one here is, this is just a normal probability distribution where they actually give you a table. And from this table, you now need to make some assumptions. So we know that all that probability will need to add to 1. So all of the probability will need to add to 1. So then if we need to work out what that one is. And and this is weird, so I don't know if there was a mistake in this, but if you look at the first answer, we know that is not 0, because if you add everything up, we get to 0.629. So I have worked out this previously, so it's not that I'm doing it in my head now. So it is 0.69 if you add that plus that plus that plus that plus that. So that value is then actually 1 minus 0.69, which is 0.371. Just imagine that is 0.371 for the moment. Okay, so that one is definitely wrong. So again, in the exam, easy, we're looking for the incorrect one, so you don't even look at the rest because that is wrong. But let me cover the other ones just that you can see and understand what we are doing. And specifically also when we use some of these signs, and I think that is important. So what this means in the option 2 is I'm looking for y values. Okay, I'm looking for y values that is bigger or equal to 0, and it is also smaller or equal to 5. So basically, from 0, including 0 till 5. So then basically that tells me it's everything. And if it's everything, it is equal to 1. The next one is another. So if we look at that sign, it says where y is bigger than 1. So it doesn't include 1 because otherwise it should have said bigger or equal to 1. So it's bigger than 1. So bigger than 1 is basically you need to add all of those together. Okay, and then it would have given you that answer as well. Another one that we look at, so let's look at that sign and I'll throw in another color. So smaller or equal to 2. So smaller or equal to 2, so it is everything that is smaller or equal to 2. And I think again, so you need to include. So bigger than 0, so it doesn't include 0. Smaller than 5, but it doesn't include 5. So it is those 4. So it's 1, 2, 3, 4, doesn't include 0, doesn't include 5, and then that would also be your answer. So it is nearly to look at this, and they can ask, and I think they've done it in your assignments as well. So what they can ask around this type of probability distribution is also to work out the mean, and they can ask you to work out the variance. So that is the two that they can still ask you with this probability function. Is one of the options could have been the mean is equal to something, or the variance was equal to something, or the standard deviation was equal to something. But that is, I think, when we get to one of the next exam papers, that will be one that we can look at there. But here, straightforward, they give you the table and they ask you questions around it. Okay, everybody happy with that? Okay, so the next one was, when I looked at it again, I thought this caught me off guard nearly, because this was not really something that I can remember somewhere in the study guide. But it's taking us back to nearly the math stuff that at a stage we did. So I can't remember it in the study guide, so I don't know if it is from previous work, and they maybe took it out of the study guide. But what this is saying is, and you will have a function on your calculator as well. It's basically 6 combination 2, and there is a formula in your binomial part of the question where it is actually, it looks like 6 factorial, and I think that is, I think that is, the formula is something like n factorial divided by, and I don't know what that was called, so I think that is something like n, and that, let's make that k. I'm just making something up now, but that was basically how the formula looks like, and I can't remember seeing something like that in this study. Say again?
It's k minus n. I don't know if it makes a difference.
Okay, so see, so dependent on.
Yeah, it will make a difference. You can't have factorials of a minus.
Yes, precisely. So it is maybe just that I'm now using the wrong signs.
It's capital N over small n.
Yes.
And then capital N's factorial on top. At the bottom you have small n factorial, and then the brackets, capital N minus small n, and then the factorial on the outside.
Okay, cool.
So your formula is very close.
Okay, so is that on a page somewhere in the study guide?
It's in the prescribed book. I checked the back of the exam paper. It looks like part of it is in a formula, but not on its own. So I want to know where that is coming from.
Okay, see, so okay, no, so that is when, so it was probably in the book and not in the study guide, but basically it looks something like this. So I'm just going to write everything out, and it's also not something that you would have seen in any other subject or anything like that you, and what that 6 factorial means, actually, it is 6 times 5 times 4 times 3 times 2 times 1, and you divide it by the 2 factorial, that is 2 times 1, and you multiply it by the 4 factorial, that is 4 times 3 times 2 times 1. And then what I then just do is I just cancel out. So what's at the top, I can do at the bottom. Basically cancelling. 2 go in there once, 2 goes into 6 3 times. So we're sitting with 3 times 5, which in the end gives me 15, which is then basically option 5. Yes, please, if you can post on WhatsApp, that will be awesome. Because yeah, I haven't seen it in the study guide, and I did definitely not buy the book. So we'll send you like 5 cents contribution for the book that you bought. Um, but yeah, so that is basically and it's, if you look at other past papers, I haven't seen something like that in any other past paper. So that was when I looked at this again, it's like, ooh, it totally caught me off guard. And obviously, I think I think for you it will also be, if you wouldn't have seen it in the study guide. So if there is something like this now in the exam, at least you know where it's coming.
Jean, we can't hear you anymore for some reason.
Okay, can you guys hear me still?
There we go.
Okay, and you can see the screen.
No. No.
Okay, so let me quickly share the screen again. I think it. Oh, wait, sorry, not this one.
No.
Okay.
Yes, we can now see.
Yeah, but it's it's the wrong screen, so let me.
Okay.
Can you now see again?
Yes, we can now see.
Okay, awesome. Thanks. Okay, so and luckily again here they said to us it's a Poisson distribution. So when we go to the tables and binomial Poisson, I always use the table and only the table. So not using the formula because that just takes ages. But so what is important here is, so they say the mean number of network errors is the 1.6. So we know the lambda is 1.6. Then they say the probability that in any given day 2 or more errors will occur. Okay, so they are telling us that if X was the errors, 2 or more errors. Okay, and I think that is important. So when I go to the table with Poisson, they told me 2 or more errors. So there's 2, there's for 1.6. So 2 or more errors is all of that added together. Okay, but what I can also do to make it easier is I don't want to add all of those together. There's just the chances that I make a mistake in there is quite good. So I can rather say 1 minus the 1 and the 2, because I know everything under that table in that line, so everything there must add up to 1. And it's the same for any other place as well. It will always add up to 1. So then I'll rather say 1 minus the 0,2019 plus 0,3230. And that will give me an answer of 0,4751. And then if I go back to this, then there is an option for that. And I think that is important when you look at the Poisson distribution and the wordings that they use, because that for me is the most important. If you said, I think there would be an answer if you added the 0 and the 1 as well. So it is very important. Wait. Sorry.
Sean,
Yes, I made a mistake
Option
here. It
2.
is 0,4751. And if I'm dyslexic, I would have picked that one as I did, but it's actually that one. Is that what you also wanted to say?
Yes.
Yeah. And again, easy to make that mistake in the exam. And it's not because you worked out something wrong. It is just because you're in a rush and you just swap 2 numbers. But that basically is a way to how I would tackle the Poisson, is to use your tables in the exam. And please, the next examples in the other exam papers also, the wording is very important, because they throw in the at least, more than, sometimes just equal to. So I think that is the important things that we need to look out for Poisson and for the binomial distribution, is those words that they use. Okay, guys, this was a quick one. I'll make the one on Thursday an hour, so that we can just get through a bit more. But at least we got through some questions and things like that. But on Thursday I'll start at question 14. Quick feedback. Does this work? Are you happy with this? Is this the way that we need to do the rest of the time until you write exam as well? And you can speak. I'm not worried. Okay, so if that helps, I think it's good.
Definitely helps. Yes. Thank you very much.
Okay.
Yeah,
Great.
it definitely helps. But I think, from my opinion, I think that if we should, like we started now with what we're struggling with, and then just later on, if we've done probability, and then just carry on with a whole paper.
Yes. So the aim is that I will work through this whole paper. So I'm not going to stop at the probability. Let's see on Thursday if we can actually finish this whole paper. That's the aim. That we do that. I think because you also get in a rhythm then on what to do next and things like that. So yeah, that is my idea as well. And then after Thursday, then you also have a better idea on the things that I need to look at for next week as well. Because it can be that you say, okay, now we understand probability, let's focus on one of the other areas. Yeah, so the plan is Thursday, the rest of the paper. Cool.
Yeah, thanks.
Thanks,
Okay,
Jim. Thank you, John.
Okay,
Thanks a lot.
Great, guys.
Thank
Have a good evening.
Same to you.
Yes. I'll make it start earlier, and I'll keep it going on for a bit longer as well. And I'll check if we can do maybe something on Friday as well. So let me just check a bit with schedules, but definitely I think we can start a bit earlier as well. And people just join as they come in. The whole thing will be recorded, so happy to do that. Okay. Until
Perfect. Thank you. Have a good evening.
Thursday, guys. Okay.
Thanks. Bye-bye.
Cheers.
Thank you.
Bye.
Cheers, John. Cheers.
Oh, bye.
Thank you.